People often ask, can laser help autism? Well, today I want to show you some research that says yes, it can. So this is the effects of low-level laser therapy in autism spectrum disorder. This was actually came out in 2018 by Jerry Leisman. So they had initial patients and their conditions, 40 kids, 5 to 16 years old, and all were diagnosed with autism spectrum disorder. They had an average age of 8 years old. And they used two things to verify their condition or to quantify it. One was the Aberrant Behavior Checklist, ABC, and they had irritability subscale scores. And all treatment and placebo patients scored an average of 30. So that's our starting point. They also checked the Clinical Global Impression Severity Scale. And all treatment and placebo patients scored greater than or equal to a 4, which means moderately ill. So it was basically, how ill do you think they are? I think the Aberrant Behavior Checklist was more effective at really determining whether there was a change in condition that's associated with autism. So what was the treatment? Low-level laser treatment. They had a treatment group and they had a placebo group. So the treatment group used the Erconia, a 635 nanometer pulsed laser with a power output of 15 milliwatts. So milliwatts, that's really a tiny amount. So the amount of energy was really small. That's actually what makes it really safe. So that's why I use Erconia, because it's super safe and they're super well researched. Placebo group, they used the same wavelength, 635 nanometer, but this was an LED and not a laser. So the difference was the coherence of the light. One was a scattered light, it's just a standard LED, and one was a pulsed laser. So all participants received the same amount of treatment, or same amount of time. So 8 5-minute light applications to the base of the skull and the temporal areas across a 4-week period, 2 applications every week with 3 to 4 days apart. So why are these areas? Why are the areas of the brain in autism? Why are they lasering these particular areas? And they could have chosen others, and I think there's some value in choosing others. So let's go through these different areas. So the brain's in autism. First, you've got the dorsolateral prefrontal area. So that's up here. There's several areas this is really important with. So working memory, that's holding information for a minute later. For example, if somebody says, hey, here's my phone number, 635-2297, and you're like, okay, 635, and you go to write it down, you go to enter it on a phone, that's working memory. Can I hold it in my brain while I transfer it or use it some other way? The next is cognitive flexibility. That's being able to change your mind, right? So this is, we think of this with kids with autism, they often have a really difficult time changing from a routine to something else, right? So you know that. Planning. So that's thinking ahead, and it's basically thinking ahead, right? Deciding what to do later. Inhibition, not doing what you don't want to do. All right, so we see this a lot with kids with ADHD as well as autism. The ones who can express it, they may say, I really didn't want to do that. I just did it. I don't know why I didn't do it. You might say, well, this is most teenagers, right? I did something I didn't want to do. I didn't know. I don't know why I did it. Right? There's some truth to that. Abstract reasoning and motor planning. Motor planning is deciding how to move, right? Planning ahead of how you're going to move. And organizing thoughts. All right? So these all work together. They're in the dorsolateral prefrontal cortex. The orbital frontal cortex represents emotion, taste, smell, and reward in decision making. So there's a lot of motivation. Those things, taste, smell, emotion, these are things that motivate us, and then that's why we make a decision, because we're being internally rewarded to make that decision. So that's the orbital frontal cortex. So actually neither one of these areas were the laser nor LED was applied to these areas, but I think there's value in doing that. The cerebellum. So this is the base of the skull. So this did have application in the study. Coordinating ongoing process, both emotion and thought, as well as other functions, including organ function. So it's coordinating ongoing processes. So super important. Temporal lobe. This was applied in the research. Facial recognition. So we know that autistic kids, especially on the right side of the brain, have diminished ability to interpret faces or what they mean. So facial recognition, as well as emotion, and of course auditory processing. All right, so this is the application, which is done at the base of the skull, which can include the occiput or the occipital lobe, but primarily the cerebellum, as well as the temporal lobe. Another thing I want to point out on this picture is the fire together, wire together. So this is a neuron. With neurons, those that fire together tend to wire together. What does that mean? Well, so neurons, we say neurons fire, right? When they're activated, when they're stimulated, they fire. And those that fire together or start being activated at the same time, they tend to wire together. They tend to connect, and one will activate the other, or they work synergistically in activating something else. And so when we do therapy, often we'll do two things at once because we want to reinforce that pathway with this summation of these nerve inputs. So what were the results of this laser treatment for autism? So the aberrant behavior checklist showed the treatment group and the placebo group both started with an average score of 30. All right, so they're the same at the beginning. There was a 15-point improvement in the treatment group. All right, that was huge in the aberrant behavior checklist, and we'll go through the details of that later. The placebo group, they received no change. All right, so that's pretty stark. It's great when you have a control group. Some studies don't have a control group, and you're like, oh, they improved when we did this. It's like, well, would they improve if you did anything? So this had a placebo group. The placebo group used LED 635 nanometer, and the treatment group received laser 635 nanometer. They also checked with the Clinical Global Impression Severity Scale, which is basically, they started as moderately ill. It's basically how ill does this child seem. The treatment group improved 81%. 19 out of 21 of them improved, or sorry, I should say 81% of them improved to a 1 or 2, which is normal or borderline, whereas the placebo group, 0% of them improved to a rating of 1 or 2. All right, so here's the details of the aberrant behavior checklist improvements for the laser versus LED. This test group was the one who used laser, and the placebo group used LED, both of them 635 nanometer red light. So that aberrant behavior, you can see that the placebo or the LED group improved almost none, and the test group improved significantly. Irritability, LED group, no improvement, and laser group, significant improvement. Lethargy, social withdrawal. You can see the test group improved significantly. Stereotypic behavior, again, the test group or the laser group improved significantly. Hyperactivity, the laser group improved significantly. And again, in inappropriate speech, the laser group improved significantly, whereas the LED group did not improve at all. So why the Zirconia laser? Why not other lasers? There's difference, and some of them are cheaper out there. In fact, there's super cheap stuff. Do they work? I don't know. So the thing is, they haven't been researched, and so it's really difficult to know if something is as effective. Is it pulsed? Is it coherent light? Is LED just as good as laser? Well, in this case, we showed that LED is not as good as laser, at least at the 635 nanometer levels. And when you get to higher levels, 835 or 810, that's infrared light, and that's actually quite effective and can penetrate more, but it can heat things up, and so there's a little more risk with that. So with the Zirconia laser, they have 22 of the total 25 FDA low-level laser clearances. All right, so there's nobody anywhere close to having as many FDA clearances as Zirconia, so that's why we like them. and there's been no side effects in any of the research. Erconia now has enough data with autism treatment for its FDA clearance submission for the treatment of autism. Okay, so FDA, you know, they take a while, and this takes a lot of, you have to answer a lot of questions, do a lot of research. Often research has to be redone because like, well, we like that, but could you check this? And so we have to check that. But Erconia is now submitted for FDA clearance for autism. The study we just showed shows that it does seem to be effective, and this gives us a specific protocol that will work.